Okay, so here is G6. So we're going to do number 2 and number 12. All right, so number 2 says find the equations of tangent lines to this graph, the graph of this equation at x equals 1. Okay, so when the x coordinate is 1. So I just want to review something. So for y equals f of x, the slope of the tangent line at x equals a is f prime of a. Okay, you just take the derivative and plug in the value. For y equals f of x, the equation of the tangent line at x equals a is very different from the slope. It involves the slope, but the equation of the tangent line, you need more to it. Remember y equals mx plus b, the point slope formula, these things. All right, so actually let me write them down. This won't take long, but these are some familiar things from your past. So y equals mx plus b, okay? This is really the same. This is the calculus form of this equation. It's a little bit different. You know, you have to do some distributing to get y equals mx plus b, but it's the same thing. This is just like a calculus version. And here's a version that's a little more similar to this, and we did it a lot in geometry. We would have point, slope. We'd put a point here, a slope there, and then we go y minus y1 equals m, x minus x1. This formula is really, this calculus formula is really like the same as this, but with y1 added over. So if you were to do that, you know, you'd get y equals y1 plus m, x minus x1. And then that really is the same, that's the same thing, okay? Because the y coordinate would be what you get when you plug the x coordinate in. There's the x coordinate, and then since we're now in calculus, the slope is the derivative. Okay, so now I'm using this website. I think it's also an app called Desmos, which is really nice. So I used Desmos, I graphed this, I plugged that into their graphing calculator thing, and and this is the graph. Now they want the equation of the tangent lines, equations of the tangent lines at x equals 1, and there are actually 3 points on this graph that have an x coordinate of 1. It looks like this one is, it looks like this point is 1, 0. This point up here, it looks like is 1, 2. And this point down here, it looks like it is 1, negative 2. But the graph is just a tool for us to try to visualize what's happening. We need to find these points using algebra. So we're going to find the points using algebra, and we're going to find the slopes at those points using calculus. Okay, so calculus is when you're taking limits and derivatives. The other stuff is like manipulating equations and plugging things in, that's algebra. So let me plug, let me say this. Okay, for our situation, this is y equals y of a plus y prime of a times x minus a. Okay, because y is the function of x, or that's the, y depends on x. It's not actually a function, but y depends on x. And here I want, my x is 1. So y equals y of 1 plus y prime of 1, x minus 1. So we're going to have to find the y values that come out when we plug 1 in for x, and we're going to have to find what we get when we plug 1 in for, you know, the slope that we get. Okay, so, guys, I'm going to talk a little bit slow, I think, because I'm tired, number 1. And number 2, this is my second take because I was trying to go too fast last time. This might end up being a long video, but in that case, I would cut down the problems, okay? But I got to take my time with this because I don't want to mess up. You could always speed up the video if I'm going too slow for you. Okay, so I've got to find the y values that come out when I plug x in for 1, all right? So let me say this. I'll say for y of 1, we end up getting 3 plus 4y minus 3 minus y cubed equals 0. Okay, I plugged 1 in for x. I plugged 1 in for x. Now I got to solve for y. These 3's cancel. So this ends up being 4y minus y cubed equals 0. And then from here, you could take out a y. 4 minus y cubed equals 0. This is a difference of 2 squares. 2 minus y, 2 plus y. So we end up with y equals 0, y equals 2, and y equals -2. So just like it looked like on my graph here. All right. And I'll just be like this. I'll say, so points of tangency are 1, 0, 1, 2, and 1, -2. Okay, so we're going to need that for later. Okay, so I've got all of my y1s. All right, I have 3 of them. Now I need the slopes that correspond to each of these 3 points. And this is the calculus part. This is where you take the derivative. All right. So for y prime, okay, so for the y prime at one part, which I'm using to find this, and there's going to be 3 of them, just like there were 3 y of 1s. Let me just write down this original. There's no need, though. You don't have to rewrite it. I know this is where I was messed up last time, so let me be careful. I'm taking the derivative. The derivative of that is 0. The derivative of this is 4y prime. This derivative, 3 times 3 is 9, so it's 9x squared. Now for this part, I'm going to need product rule. So the derivative of x is 1, so it's -1, but you bring down the y cubed. Then you bring down the x. It's usually a plus in the product rule, but I'm distributing the negative in my head as I go. Now the derivative of y cubed, this is what I messed up, is 3y squared y prime. I said 2y squared. Okay, equals 0. Now, if you were just finding y prime at one point, then what I was recommending before is that you don't solve for y prime, you just plug the x's and y's right in here and then solve for y prime. If you're in a situation where you're just looking for the slope at a single point, then I would still do that. I stand by that. However, since we're going to have to plug in 3 separate points to find 3 separate slopes, it makes more sense to get y prime by itself now. Okay, so let me find my y prime terms. Okay, there they are. So, and you guys can, a lot of you are doing this in one step, which is just fine. Okay, but since I'm making a video, I'm going to not do it that fast. So and even when I'm on my own, to be honest, I often don't do this in one step because I tend to make mistakes with like negatives sometimes. So minus 3xy squared y prime equals, and this is y cubed minus 9x squared. Okay, I think I'm right. This. Okay, now you factor out the y prime, and then So this ends up being y cubed minus, I am skipping a step here. When I factored out the y prime, there was stuff left in parentheses, and now I'm dividing by what was left in parentheses, which is this. Okay. Now, all right, I'm going to get 3 of them. So, let me maybe move like over here. At 1, 0, y prime is equal to, so 1 is going in for x and 0 is going in for y. So what do I end up with? Just negative 9 over 4, I think. What am I doing? What one am I on? I'm on number 2. Is it negative 9 over 4? Oh, okay. I wrote this down wrong. This should be minus 3x cubed. All right, I'm okay. So that's a minus. So that's a minus. So that's a plus. That is a plus. You probably saw that. Okay, so when I do this, I end up getting 9/4. All right, I'm just plugging in for x and y. At 1, 2, y prime is equal to, to save time, guys, I'll just kind of like say what I got earlier, but you're plugging in 1 for x and you're plugging in 2 for y, and we end up getting, what do we end up getting? I think negative 17 over 8, right? Because if, all right, 2 goes in here, so that's 8. 8 plus 9 is 17. I'm going to sneeze, sorry.